the exhibits downstairs, the posters, the demonstrations, outer space corridors, sunspot viewing, telescope models, what have you. And you all want to come and work here at some point or become an astronomer, which is why you're here in this session to learn how to be an astronomer, right? So to tell you that is Professor Maheshwar Gopinathan. Maheshwar Gopinathan is a faculty here at IIA. His work is on star formation, but he's here in his capacity of the chairperson of the Board of Graduate Studies. So he's the person you have to talk to and impress if you want to do a PhD here. He did his PhD in star formation here, after which he went to Aryabhatta Institute in Aries in Nainital, where he worked for quite a number of years as an astronomer, and there he was in charge, one of the people in charge of installing and constructing a new telescope, which is the dot, the 3.6-meter dot, which is the largest telescope in India currently. After which he spent a postdoctoral fellowship stint in Korea, South Korea, I'm assuming. Yeah. And after which he joined here as a faculty. His work is on star formation, interstellar medium, magnetic fields in gas, dust in interstellar medium, and so on. But here he's going to tell you all how to become an astronomer, or rather how to engage with astronomy in many different ways based on your own interests. So, Maheshwar.
Yeah. Thanks, Neeraj, and welcome you all to this session. Let me begin by saying that 25 years ago, I joined this institute, like I think many of you, and I had no idea. I had no idea about astronomy. I just knew what physics is, and I looked at the advertisement which came on the newspaper. I applied in here, did my interview, and got in inside. But nowadays, thanks to many outreach programs, now you are exposed to astronomy in much better way than we used to have. And thanks to all parents, because they are taking pain in coming here, bringing you students to this place.
Increase the volume.
Yeah. So thanks to all the parents for bringing your children here. Spending a whole day here basically. So all right, so I'm going to tell you nothing about the long list that Neeraj told you. Don't worry. I'll be just telling you about how you can take up astronomy as your career, not as an astronomer, but as in many ways in which your interest aligns with. But first of all, let me say that it's not only the parents who are taking interest. It is the government also playing their part in bringing up what is called STEM education. Basically, it is the science, technology, engineering, and mathematics. It's basically the idea is to inculcate what is called the critical thinking skills and problem solving skill in the children, and it also integrates the multidisciplinary that you can think about. And why I brought this thing here is basically because the national the science policy actually talks about the STEM education in India, and if you look at astronomy, you need all of these. You need science, your understanding in physics, of course, that is the most important thing that should have. You also need to have understanding in chemistry, in biology, in technology, engineering. I'll tell you why it is needed. Why I'm emphasizing on this is that I was in one of our observatories, and students used to visit there. And one of the kid came to me and said, "I don't want to do research." I said, "Why?" "Because I have to discover a star." That is not the thing. You don't have to discover a star to do research, but what you have to do is you have to have, a curious mind. You should have a curious mind, basically because certain observations that you make. Have you ever thought of why ants move in a line? Why is it that, how is that the birds migrate from one place to another? These are basic things, things which you observe around you. Nothing to do with astronomy, nothing to do with any big science, but it is the curiosity that comes into your mind. And this is where our education should move towards, basically. Basically ask students, how many of students have thought about it, like, in the class, instead of reading about definitions, derivations, calculations. How many of you have stopped and asked yourself these questions, which are trivial, right? Every day you see, you put some sugar cubes in a room. After 5 minutes, you see all ants are there. How they are identifying it, how they are sensing the presence of sugar cube there. Have you ever thought about it? The volcanoes that are coming in. I'm going, bigger things, like, you come to eclipses. You recently heard about the planet alignment, right? How the planet alignments happen. And of course, if you have proper gadgets with you, you can see galaxies like Andromeda, right? So, which is like groups of stars. Not only sun, we know about sun, but there are groups of stars. You might have seen many posters here where people are studying about stars, galaxies, universe, what all you can think about. But then in all these things, as I said, it is the questions that you ask which is the most important thing. And one of the philosophical questions that you ask is the origin of life on earth, right? How it came, or are we alone? But then there are many other questions which are like connected, which comes into your mind, which is related, but it gives you a bigger perspective about research. Why I'm saying this is, research is not in isolation. It is something which should be naturally coming to you, because you are asking questions. You want to look for the answers, and then to find those answers, you have to build equipment or instruments or telescopes, what all things. For example, the one of the question that comes in, that we can, I have taken it as an example, is how old is our sun? How many of you have thought about it? You know, but if this, very good, if this question we ask, we have to be like a Sherlock Holmes, or like a prosecutor who looks for evidences, and then you put everything together and then find out a solution. Now, connected question is, how old is our Earth, right? Because these are connected, isn't it? If I can find the age of the Earth, then I can find the age of the sun as well, because the sun has to have the minimum age of the Earth itself. I can even look for other evidence. I'm not going into detail, but you can do something like, check for the nickel 60 in meteorites, or other solar system objects. You can actually get back and get the same answer. So it is like, you ask a question, you got some number based on certain analysis and observations, but then you have to attack that using different ways, right? Because everything has to lead to a same answer, if that is the truth. And you can see that it is, very close. We are actually estimating the age of the Earth or the sun with quite accuracy. Now, you can even improve it if you have better instruments. So what it tells you is that research is nothing to do with discovering something. It is, you have some question, you pose that question. Now, to find solutions to or answers to that, you list out what are the things that you require, and then you study for it. If you look at using a telescope, you take a picture, you see many stars, right? Many objects, not only stars, there are many things. What are the things that you can ask yourself? Anybody? The questions that can come to your mind. Yeah.
How many stars?
Very good. How many stars?
Are some of them brighter than the others?
Some of them are very brighter than the other.
Why are they different colors?
Absolutely, they are
What
different.
they're made of?
What they are made of?
How far are they?
How far are they? How old are they? Why are they there?
Are any of these
I know.
galaxies?
Most fundamental question: are there anybody out there like us? Isn't it? So these are certain questions that comes into your mind, and to answer all these things, what we do? Yes. Something to say? Yeah.
How, which type are they?
Yes. Very good. What type of stars are they, and what is the age? The stars have a life. They take birth. They die also, right? So how are they formed? Where are they formed? What are their masses, the sizes, right? So you can actually study all, the information that comes from these objects. And what is the information that you get from these stars? You cannot go there.
The waves that are coming.
Only the light that is coming,
Light they emit.
What are
right?
they made of?
Yes. So you can get answer to all these questions only using the light that is coming from them, right? But unfortunately, atmosphere doesn't allow us to collect all the light. What it allows us to collect
Visible light.
is the visible light, which our eye is sensitive to, right? It may happen that, you look at the evolution, right? I mean, eye is sensitive to the light which atmosphere allows it to come in, right? Just imagine if our eyes were, apt to radio, not you couldn't have, seen anything, right? So you see, if so only optical which comes to the ground, that means you can put many telescopes on the ground and you can collect these lights and study them, right? But if you want to look at, say, something like, these wavelengths, this is as a function of height. So you can see, if you want to study this, then you have to go higher. That means your instrument has to be put on a plane. There is a 2-meter telescope in an aeroplane, and it flies around and observes the stars. Now, if you want to go even higher, for example, in UV, does it come to Earth? We all would have been in trouble, right? So to detect UV radiation, you have to go above the space, right? You can even go too far now. You can go to L2, Lagrange L2 location, where you can get, the infrared observations. How many of you know about JWST? James Webb Telescope? Very good. So this is the telescope. It's a 6 meter. When I say 1 meter, 2 meter, 3 meter, 6 meter, it is the diameter of the primary mirror of the telescope, right? So this diameter is basically the size of the telescope. So you can see that 6 meter telescope is in space, collecting radiation coming to it, and basically giving us an evidence of, signatures of what is happening in celestial sources. This is the biggest telescope that we have. It's very, nearby. This is the biggest telescope which India made. It's a 2.34 meter telescope in Kavalur, in Vellore. This is the Devasam optical telescope which Neeraj was talking about. It is the biggest telescope in India. And you can see that they are all enclosed in something called dome, right? Now, basically to cut out the light that is coming from elsewhere. So you don't want stray lights to enter to the telescope. You have seen this model of the telescope, the laser by which you can, so that is basically, so you have to protect this. Now, some domes are hemispherical, some domes are cylinder with a tapering top. Now, all these things are basically done by, engineers and people who are in technology development, basically to do simulations on, because we don't want turbulence. How many have seen, stars twinkling? Right? We don't want. We don't like it. So you go to space, will it twinkle? No. No, it won't, right? It's basically because of the turbulence that is created in the atmosphere. So if any faulty design of a dome, it can create turbulence and it can actually make the stars. And we don't want that. We want it to be as sharp as possible. Why do planets don't twinkle but stars?
Stars are considered point sources of light, while planets are contain many point sources as well, so they don't twinkle as much and also they're closer to the Earth.
Basically, it's a nearby, so the light they produce is not too much, as much as affected as the light from faraway stars.
Okay,
Also, point source. Plants are farther extended.
extended source. And do you know the smallest telescope that you can have?
Microscope.
You're right, basically. So if the light is falling into your eye, you can see it. If it is going off the eye, you cannot see it. So basically, whenever you're seeing the star, it is passing through the eye. And if it is not, so that is why twinkling means it's coming and going, right? Basically, it's because it's not going through your eye. So it is the turbulence. So we don't like turbulence to happen in stars. So and there are certain telescopes where you don't need dome. So the design is such a way that you are not keeping dome, because when you're looking at infrared, is there an infrared detector, right? Have you seen infrared detector? Have you seen you all radiating in infrared? Right? So if you are observing in infrared, all these structures will emit infrared. That means your detector will be filled with the background light itself. You don't want that, right? So you take away all the dome and keep the telescope as bare as possible, right? And you can have very funny, like, this is the 30-meter telescope which India is part of. Is a 30-meter means it's a 30-meter dia of the mirror. And you can see the, very peculiar shape of the dome. So what the point that I'm making here is that astronomers come up with question. They want to answer that question. They want certain observations. It is not observers or the astronomers who make it. Of course, they are part of the project, but it is the engineers and the technology development people who are actually involved in this. This is the TMT is basically, as I said, 30-meter with about 500 odd single segments. So the primary mirror is made up of 500 odd single mirrors, and all these mirrorlets are, a good majority of the mirrorlets are actually shaped or figured in very close here. It is in Hoskote. And this is IIA's facility where the grinding of the, so this is basically a circular mirror. You polish it, you grind it, and then you cut it in an hexagonal shape and then put it. So this will, each hexagonal segment will form the primary mirror. So this grinding and, figuring of these mirrors are done here, and many of the engineers are part of this. Then this is a gamma ray telescope. So anybody, yeah?
I just have a question. Why do they use hexagons?
So these are like, so why it is hexagon? Because it can fit together. So if you have a circular mirrors, so if you make a big mirror with circle, there are these gaps, right? So if you have a hexagon shape, they can fit in very well. So that is the
Triangles.
Yeah, can't triangles and squares also do that?
It can be triangles also, but then making them is not a trivial thing, because you have, many corners, right? You have this, the cutting has to be done very precisely, otherwise it will be a problem. And also it will not fill. When you go to your edges, how are you going to finish with the circle? Will be a problem, isn't it? So that is the reason why, the hexagons are preferred over, any other shape. Yeah.
That was the question.
Okay, fine. So you can have, this is the gamma ray telescope, which is again in Handley. Can you detect gamma rays on the ground?
No.
So it is done basically in a Cherenkov method. Basically, it produces secondary particles. Gamma rays produces secondary particles in the atmosphere, which is detected. Okay, and then of course you have this giant meter wave radio telescope in Pune, which is GMRT, and you can see the dishes. They are not filled like this. There are gaps. Maybe you can find out why it is so. And then gravitational wave observatory. How many of you know about gravitational wave? So if any compact object spiraling in and collapses to form a single one, you can have the gravitational wave coming in, and this is another way. So your space will be, disturbed, and that disturbance will give you what is the mass of the sources which have collapsed. So this is additional, it's not radiation, right? It's not only photons that you're detecting. Basically, it is the gravitational wave also, isn't it? Now, what are the information that you're collecting? You're basically collecting the information like the light in different filters or different wavelengths. So this is the wavelength. So you are actually collecting light from different wavelength, the same source, that will give you additional information about what are the physics that is happening in these sources. You can even do spectroscopy, right? You can, for example, if you take spectrum of a source, then any gas which is present will give you characteristic lines in the spectrum. So by doing photometry and by doing spectroscopy, you can collect a lot of information about the sources which you are studying. And you see, the spectrographs were very small, but nowadays the spectrographs are like, this is a telescope. So it is the size of the telescope itself. Or now it is for the 30-meter telescope, the spectrographs are like this room or a double-story building. So that is the complexity that it is taking. And for spectrum, the days are gone when you used to observe only one sources at a time. Now you are using multiple, thousands of sources you can observe in one shot, because all these cylinders that you can see here, these actuators, these are basically arms which are which are holding fiber tips, and these arms can move and fiber tips can move to connect, to find a source. So you can get the spectrum of many sources in one go. And what are the information that you are getting? Now, this is a planet. We've seen a model which is there on display, where you can see how a body goes around another one, and you can see a dip on your tablet. Now, this is basically one such observation where there is a dip because this planet comes in front of the star. And this dip will tell you what is the diameter of the planet, how it is moving around, and the spectrum, right? This is a spectrum of a star, and you can see all these lines are basically giving you information about the elements which are present in that star. Now, you got data, so you have problems. Your engineers build you telescope and instruments. You have collected data, but you have to analyze it. Now, how do you analyze it? For that, you need softwares, right? So you need, software engineers basically, or the people who, astronomers themselves have to understand the software and develop the software. So these are the softwares which are, as an example where you can actually get what is the dip in these lines happening, and using the dip that it gets, you can actually understand what is the physics going on in these sources. Now, this is the data volume that it is as a function of year, the data volume that we are producing, and you see it is going into terabytes, right? And you cannot, as a human being, you cannot, study them individually. What you need artificial intelligence, you need machine learning, and see the complexity of the. So every star is of a different nature, right? Now you cannot sit and say, okay, this is this is this. It is going to take an enormous amount of time. So you need machines basically to help you out in classifying the sources. And of course, you have to have mathematical skill, basically. So you need to have the curiosity, you need to have the ability to ask questions, you need to have the ability to find right way or approach to attack a problem. You need engineers basically to give you telescopes and instruments. You need software engineers basically to give you softwares to analyze the data, and you need mathematicians or mathematical skill basically to understand what are the things happening in these sources. I have listed out some of the abilities that you should have, but the prime thing is the critical thinking and analysis and attention to detail. These are two of the most important things that you require if you want to take a research. Not forget about astronomy, research as your career. And of course the time management, because you have to finish within certain periods, so you have to be very dedicated in doing your work. And other abilities basically comes along. For example, your communication skill or writing skills, these are also important, right? And whatever you are finding out, you have to tell these things to the people. So basically those are the things that you require. And of course, if you are dealing with mega projects or big projects like 30-meter telescopes, your astronomer has to be good at managing things. Or you need to hire people who understand astronomy, but who are good in having management skills, and also the financial skills. So it's not only the scientists who are in demand. So if you look at it, I mean, these are the things which you require if you want to say look at a mega project like 30-meter telescope. You have to have technological skills. You have to have the educational skills, and also you need to have something called outreach skills. Basically, the things which we are doing today. You have to go to the public and tell them what we are doing. Basically, at the end of the day, it is the taxpayers' money that we are spending on it. So it is our job and duty to tell you what we are doing it and why we are doing it. These are some of the facilities that we have in India, basically as a function of wavelength, and you can see the wavelength and the facilities. So this gives you a kind of what are the available ones and what are basically planned in future. And these are some of the telescopes which are scattered all over the India. So there are many institutions which are dealing with astronomy. So it's not only IIA or the institutes which are in Bangalore, but they are scattered all over the country. And so I have distributed or classified the institutions into two categories. One where astronomy is the main stream, and other where at least one department is dedicated for the astronomy. So you can see Indian Institute of Astrophysics, IUCA, which is in Pune, NCRA again in Pune, and Aryabhatta Research Institute in Nainital. So these are the four which are dedicated for astronomy and astrophysics. Of course, Aryabhatta Research Institute, Aries is involved in atmospheric sciences as well. And these are the institutes where at least a department is dedicated for astronomy. The list goes on. There are now IITs and IISers are coming in. So there are many institutions. Now, the good thing about this is that means that job opportunities are also going, it's going up. It's not that only you are going to get into only selected institutions, but if you are taking up astronomy, you are in demand in taking a job in many other institutions as well. The list goes on and on and on. Now, there's the one question that people ask is, do I have that, ability, the research ability in me? For example, those who are doing, say, final year undergraduate or doing masters, they can visit us. They can come to IIA as a visiting students under visiting students program, where we give a period of 3 months for you to come here, spend time with us. We give stipend to the students. So you have to convince any one of our faculties that why you want to, spend say 3 months with us. We will give you data and or calculation problems and all, where you can actually come here and get real-time experience of how research is done. There are summer schools and winter schools conducted by us and elsewhere also. Now, IIA has four PhD programs. The first one is IIA Pondicherry University, and the second one is PhD program with the ACSAR. So we have a tie-up with them, and then the PhD programs are conducted in collaboration. Applications are invited twice a year in April and October. The information is given on our social media as well as the print. You can keep a track of it. And there is another one which is IIA Calcutta University. It's a very unique program because you can do MTech as well as a PhD in instrumentation in astronomy. Because why we have started this program is because you might have seen the kind of instruments that we require. They are of specialized, right? And high precision is needed for our purpose. So we want people, engineers, basically, who are good and have the astronomy zeal in them. And then the last, IIA has a collaboration with Indian Institute of Sciences under Joint Astronomy Program. It's called JAP program. And students who are enrolled there can come here and do their PhD as well. These are some of the research areas that we have. You can see that the research area starts from sun to cosmology and not only observational, instrumentation as well as theoretical topics are also covered. And these are the the requirements, the education requirement. Basically, we ask for physics. So if you have MSc Physics, then you are most welcome here. And there are other streams also. We don't ask for astronomy requirement. That is a secondary. If you are very good in physics, that's all that we ask for. Then if you want to get into MTech and PhD, you can do, you can come through MSc or BE BTech. Now, how can you apply? Now, you have to have cleared at least one of these three exams. JEST is Joint Entrance Screening Test. It's going to happen in April this time. Then GATE or CSIR NET, UGC NET. And you have to have 95 percentile or above for applying. Now, the students who are, once you are shortlisted, you have to go through an interview. And once you are selected, you are in as a JRF, and your stipend starts at 37,000 per month. We have a hostel facility also for it. Now, so the PhD program is for 5 years. So after completing your 5 years, normally our students go for postdoc, mostly abroad, but they sometimes take up postdocs in India as well. And then they come back as a faculty like me. So, and then what are the other ways in which you can practice astronomy? So whatever I said is the classical way, right? You do a master, you do undergraduate, masters, and then you come to PhD. You can actually get into any industry. For example, 30-meter telescope. There are many industries working with us, and the people who are working has nothing to do with the astronomy for till now. But now they have got into the astronomy through those industries, right? So in that way also you can get it. You can be part of planetaria. You can be a public outreach program. You can get into as an educator. I mean, we give a lot of emphasis for that because you can see the institutes are very limited, but planetaria is having a wider reach to the public, right? Where students can get motivated by seeing the phenomena through in the planetarium. You can even do history of astronomy, right? And also you can be an entrepreneur, set up your own companies, which can actually help us in getting new technology. There are a lot of startups, space startups now, which the government is encouraging, and these are basically so we don't have to now look into the technologies. They come up with the technology. We have to worry about the science programs that we are interested in. And you can be, can make movies, right? You can be a cartoonist, and you can be a photographer, right? And you can be a painter. By the way, the next talk is from this gentleman. He is an engineer with us. I think he was here. So you can be a photographer. So you see, the astronomy has, need to have everything, right? Need to have technology skills. You need to have science and research. You need to have even the cultural, right? You need to know about the history, what people used to do, and what we can learn from these. So it has a holistic, stuff. And people say sky is the limit, but I would say sky is no limit. So search for the stars. I'll stop here and take the questions. Thank you.
Good afternoon, sir. I had a question. If I want to do pure astrophysical research, what programs or courses should I do, either national or international? Thank you.
Okay, so if you want to do a pure astronomy related thing, then I would say just concentrate on physics. Yeah, and take a master's course in physics. Yeah, I mean, as I said, we don't look for your astronomy knowledge at all. So it's the physics, the basic physics. That is what we do. So learn it. So, okay, I'll tell you one more thing. For if you have cleared the exams, I never told you that how much marks you should score, right? So we look for 60% for your entire career. So if you have 60% and above, you are in. We don't look for rank holders. We don't look for the very high marks. No, if you have cleared the exams and if you know physics, you are in.
And there is no backups or anything. It should have backups.
Which
But is there any backups on everything?
I didn't understand.
Say the guy has
Backlog.
without any backlogs.
We generally, so we say it is like, if you have a final exam marks greater than 60%, yeah, we don't generally care about it. The only thing is the interview.
Colleges are required to announce a backlog.
No, we don't look that way. If you have your 60% cut off for us, we are happy.
Before we apply for the PhD program here, should we have a degree in physics?
You should have a master's in physics.
Hello, sir.
Yes, please.
I'm a homeschooler and I learn physics in maths. How to get admission into IISc for astronomy and astrophysics?
Again, MSc, Masters in Physics. So if you have Masters in Physics, and there are, by the way, integrated PhD as well. So you can even do an undergrads and get into. But physics, again.
Okay, sir. Thank you, sir.
So, what would be the best places in India for studying physics after schooling? Graduation.
See, to get into astronomy, you need to have some basic understanding, right? Because this is not a basic science, but it's an applied science. So you need to have certain knowledge. So we generally don't prefer students to come here after their schooling, other than just do some reading projects or something like that.
No, not here, but
Yeah.
Where should they enroll? What are the good institutions for physics?
So it's like after 12th, you're saying? After 12th, for bachelor's or undergrads, there are universities which offer astronomy. So there you can go, but I think the options are not that very much, but
No, for physics, you said that initially you should study physics.
yes, for
So-
that, you see, it doesn't matter where you are doing.
Okay.
It is the physics that you understand that is more important. Even if you study alone, it's the concepts, understanding of the concept which is more important.
Basically, it's BSc in physics, if you take bachelor's and master's. There are many
It is
schools
basically
and
masters,
colleges,
yeah.
So what's the intake here?
Oh, so intake, so it depends on how much capacity we have because we give accommodation for them. So it depends on that. So normally it is about 10 to 15 per session, per semester. Yeah.
So it's for like PhD.
Yes, it's for the PhD. But for masters, or if you are interested in astronomy masters, then there are many options. Yeah. But for PhD, it is very, it's like, so we take 50, maybe other institutes also take off that the same, like, it's not very different. So maybe 15 to 20.
Can we do a master's in physics here?
You cannot do masters. We offer only PhD.
So you guys think about offering apprenticeships to schools? That something we want to make?
We can do, but then again, the thing is, we can offer only a reading project. We cannot give, say, you see, it's a data intensive program, right? So the student should know at least some basic stuff. Otherwise, the danger is that they come here with a lot of hopes, and then they see high-end stuff that is required from them that will actually demotivate rather than, motivating them. So we don't want, but there are like shadow days conducted here where students can come be with a scientist for a whole day. I mean, the student will be just with the scientists and what they are doing, all those things they observe. Okay, and then give a report basically like what they observed and how, like often people say that the scientists are like crazy, so that's not the picture that we want to give them. So it's like we are normal, but what we do, so they will get an idea about it. But other than that, it is a bit of a difficult, but I would say it's like the school students, they should be curious to ask questions, basically. Yeah.
For the integrated MSc MTech program, is it again after MSc or after PhD?
So integrated MTech,
MTech.
MTech
After
PhD.
MSc, yeah.
So that is for MSc as well as BE Tech. Yeah.
Not after BSc.
Not after BSc.
MSc or
BE Tech. Yeah. Basically, we want engineers, for building instruments. Right.
Is there scope for disciplining research from the research in astronomy to fields like guidance, navigation, control, and in machine learning?
Yes. So it is, as I told you, right, terabytes of data is going to come, and it's basically a pattern matching, right? One star will have certain pattern of signatures and other star will have different. Now you cannot go and look for each, but you create a database of patterns and then put all the data that you're getting from other stars and feed it onto it. So this is like pattern matching for billions of stars. So I mean, the scope for machine learning is enormous thing.
Is there a formal way of doing it here? There's some mentorship program that goes on with the scientists from here.
There are some faculties who are into machine learning as well, but then you need to have very high-end machines, which we have. So yes, there are. Yeah, if you're interested, you can take up an internship for 3 months. So what we do is we give initially for 3 months. If the student has the capacity, then we extend it for 3 more months. And if something is coming out like a publication or like a result which you can publish it, then we give 3 more months. So it's like we also look at the progress of the student as well as the faculties in the feedback. And then so you can, if you are interested.
Like you said, physics is the basic thing for applying, I mean, for going to this field, and BE Tech, which is the closest branch to this.
So computer science, electronics, then maybe aerospace,
Aeronautics.
yes, then optics. Optics is a very major component because you can see, so there are many applications. So yeah, so these are the main things. Yeah, mechanical.
There are undergraduate courses now coming up in astrophysics, right? So you keep repeatedly saying that physics has a bachelor's or master's is everything. So do you encourage like astrophysics at undergraduate level, or they should still be strong in physics?
I would say you take up anything, but there should not be a compromise on the physics. Yeah, that is a must because that's what we are looking.
How does the typical career progression for somebody in this area? Do they do like postdoc and then PhD? We have something with research, or what is the typical career progression?
Oh, so I should have put that as well. So as I said, after the students do PhD, they take up a postdoctoral, position elsewhere. It can be Normally the postdoc tenure is for 2 years. They can take two of such things and then apply back and come back, or they can stay wherever it's up to them. So it's like after PhD, go for postdoc, and then they get trained into like researchers.
It's very research focused.
There are many people who have gone to industries, right? How many of you know adaptive optics? So adaptive optics is basically be used to stabilize the star. I said no, there is seeing problem, right? So it disturbs. So adaptive optics is a technique by which you can actually stable the image of a star, and same technique can be used for your imaging your eye. For example, if there is a trouble in your eye, you want to see which one, where is the problem. Now these are so small that if you are imaging, they get blurred. So adaptive optics can be used to, so one of my seniors have gone to and, have set up basically a company which does this. So you can be an entrepreneur also. So you don't have to stick into research. You can go into, creating some startups.
Excuse me.
So what is the minimum qualification for the winter and summer school for the internship programs?
So for the internship programs, either you have to be in the first year of masters or the final year of undergrad. BSc also we give, but normally the sheer number of applications that we are getting from the masters is so high that we normally, give it to those. And for the summer school, again, it is the masters.
Just want to voice out for the school children below 10th and 12th. With any IT industries are having a lot of incubation like IIT Jodhpur, IIT Himachal will come with incubation cells for students who are into R&D and research. Are there anything such for the school students that is a K-12 category who are interested in physics, astronomy, or even robotics with moon dwellers? Because you have few students, I support as a credit counselor, few students who have been working on prototype robotics on dwelling moon and other things. So do you have anything such for school course?
We don't have a program by say for that. Okay, but definitely that is something which we can think about in in bringing astronomy to more schools level. So I think there are our outreach program people visit schools and give talks and presentations. Even there are programs where we take telescopes to the schools and tell the students about astronomy, but we don't have a program per se for that.
I have requested us to actually work on microbeams and space-based solar power, which many few kids are inquisitive in this area. If we can support such children into science at an early age, it's good, and I'm really happy with
Definitely, we can think about such programs. You can reach out to the scope, the people who are conducting this program today, and they can help you out in that. Some of them are, yeah. That is true. So either we can think about a program where we can actually make digital books available to the people, because if see our library is not very big. So as I told that our intake is about 15. So we are a small institute, and library is not that big to bring in more students here. So maybe we can make these books available online so that students can read it. I don't know whether there is a breach in the copyright which we need to look into. But otherwise, in a very limited sense, we allow. So there are students who come here like reading projects from the school. They come here, they read, and then they can even talk to the people here. So there are limited programs, but as I answered to ma'am, that we don't have a program per se to do it. But if you are approaching us, I don't think anybody is going to deny. Yeah.
Yeah.
Yes.
How can I start off as with my like career in astrophysics or astrobiology, something like that?
I would say don't start your career as an astrophysicist. You start asking questions like what I said. Be curious to the nature, because that is going to motivate you to learn what you want to understand, basically, right? So and keep looking at sky, basically.
Excuse me. Okay. There are some YouTube questions. So Karthik Sangula said, "Can I join IIA for research programs after my current master's in space science and technology?" He got his degree from University College Dublin.
That I need to look into, because degree from abroad, right?
Yes.
We haven't got such cases yet. So
Yeah.
yeah, it's a policy matter. Yes.
And the second question is,
But you can write to us.
okay.
And definitely we'll get back.
Yeah, so Karthik Sangula can write to IIA. The second question is Soumya Shri Desai. What options for learning are available for quantum cosmology or cosmology?
Can you repeat the question?
What options for learning are available for quantum cosmology or cosmology? Quantum cosmology.
Okay. So I think there are
Yeah,
lot of
YouTube.
YouTube videos, right?
Yeah,
No, there are a lot of YouTube videos where you can get information about very basic stuffs, because there are several lectures available online which he can explore, and he or she can come and discuss with any of the faculties here if they are interested in getting more information about it.
Just one more question. Last, Vinay asked, can I apply for internship program in IIA this summer? Basically, it would be like, what are the internship cycles in IIA?
Okay, so we used to have cycles where you can apply and we select students, but we found that to be not very efficient. So individuals can approach any of the faculties, they can look at the profile, and because otherwise, when we are selecting and giving, it's our choice. Now we are giving the choice to you. So you can actually select based on the profile of the faculties on the web, and they can contact the faculties directly. And if they are interested, if there's a mutual understanding, they can write to Board of Graduate Studies, and we, yeah.
Thank you, sir.
Yeah.
Any specific courses for higher
There are, so okay, so once you're selected to IIA, you have to do some coursework, right? You have to clear certain papers, and then only you will be allowed to go ahead with your PhD. During that time, we give high energy courses. Okay, but then there are uh, there are high energy courses in some of the universities. For example, we have tie-up with Pondicherry University. We teach them high energy, the students there, we teach them. So there are like that tie-ups with where university institution tie-ups are there where these things are taught. But so then you have to look into universities where astronomy is there, if you're particularly interested in it. Yeah. And then you have a lot of YouTube videos. So now things are like what we teach, we put it on the YouTube, and you can get information.
I wanted to know more about the PhD. So that PhD is for instrumentation.
Yes.
So the research work would be based on astronomy, or it would be needed for design.
So
Carried out. It go to other IIA.
Okay, so I said there is IIA has a tie-up with ACSIR now. So that means there is a possibility of carrying out research in CSIR labs as well, right? So that is one option. Another is in MTech. After MTech, those who are doing PhD, they do it here. The facilities that I showed, and they do it in various things. For example, they do it in detectors, the ground-based and space-based detectors. Some of them are doing in you know the segments, right? The telescopes, each mirror segments. Now they have to be supported very delicately. So there are research going on in how we can improve this the structural things. So that means mechanical things are coming in. There are space-based telescopes that are being made. Recently, we have sent a payload in POM with the ISRO. So people, students are working on that as well, and there are people who are working in, say, in bigger telescopes abroad. They are like taken a tenure track positions there. There are some of our students have gone to startups, um, even in Bangalore. So it's not only that you are in IIA, because the instrumentation that you do here is at a higher end, right? Your technology is, so you are highly skilled. So your employability is also more. So you don't have to stick into astronomy field. That's what I'm driving here. That is true. It is more towards, but there are students who do both. You know, for example, they have a problem and they want to study that. That means there is a specific instrument with which they can do that. You design that instrument, you get the data, so now you can actually go into both the streams. You can actually take up a research as well as you can go into instrumentation. So
Okay, we should wrap up,
yeah.
I think. Yeah, there's a lecture at 4 o'clock, a talk by Dolce and Club. So see you there. Thank you, sir.
There's professions like